Welcome to 23rd lecture in the course of Industrial Engineering and Operations Research. Today we are discussing a finance related topic, that is break-even analysis. Already I have discussed in part 1 of the lecture. Now today is the second part of that. We will be little bit understanding it more because this is an important topic. So that break even means that if you are producing some quantity, your production level is like that there is no profit, no loss. If you are getting some loss, it may be due to your fixed cost being very high, and therefore you have to recover that fixed cost. Suppose you purchase a car and you use it as a taxi. Naturally you need minimum number of passengers per day, so that your cost of purchasing that car can be recovered. So this is very important. Otherwise, if you keep the car in your home idle, then you will have to pay the loan amount on that car anyway, and there will be expenditure on the driver's salary, etc. also. So driver's salary is a fixed, car purchase price was a fixed price. Out of the, if you assume that the car will give service for 10 years and suppose you simply use straight line depreciation method, so you have to recover 1/10 of the purchase price of the car each year. So naturally that thing is there, and running expenditure will of course will be there, that is variable cost. As many kilometer you run, that much petrol has to be spent, that cost is also there. So that is why break even analysis will tell that to recover the fixed cost and make profit, you have to do some minimum amount of production or service, whatever is the thing, and then you can make some profit. So at break even there is no profit and no loss. Let us revise some of the equations which we discussed. Okay. So this is like important formulae. So in break even point, in terms of the units, we said that it is fixed cost divided by contribution per unit. And what is contribution? This terminology one has to understand very carefully, that fixed cost means that cost which will be anyway incurred even if you do any production or not. Suppose you have purchased a car, so fixed cost is of course driver's salary that you have to give whether you use that car or not, and similarly the depreciation amount of the car, that also you have to give. So that type of thing is already there, fixed cost. But what is contribution per unit? Contribution means contribution per unit. Contribution will be what? Is equal to, this will be sales per unit, that means at what price you are selling, sales per unit, minus variable cost per unit, cost per unit. So if you consider that suppose only the petrol price is the variable, so suppose you get a, say somebody pays you 50 rupee in a kilometer. So let us say 50 rupee in a kilometer in some vehicle, and assume that vehicle is very efficient. So therefore whatever fuel is used, that may be only, let us say 40 rupees per kilometer. So therefore per kilometer you get a contribution of 10 rupee. That means 10 rupee excess, because you made a expenditure of 40 rupees on purchase of the fuel, but you charge from the customer 50 rupees. So 10 rupee was extra, so it is called contribution because it will contribute to fixed cost. So that is how it is done. So, break-even point in units will be that, suppose this comes out to be, suppose 10 rupees 10, you can say rupees 10 per kilometer, that much you got. And suppose fixed cost per day was something like 100 rupee per day. Although you will have data like, yearly how much you have to recover from the car, then you say that monthly, let us say you decide that yearly that you have to recover 1 lakh, then monthly you divide it by 12. Similarly, you can find out daily. So, if you want to find out that what is the break even point in units, that means how many kilometers I should move my vehicle or utilize my vehicle per day, then you can do that, suppose per day fixed cost. So, per day fixed cost you find out, okay. That means whatever is the cost in month, that has to be divided by 30, and then suppose it comes out to be 100. So, 100 is the fixed cost, but 10 rupee per kilometer is this. So, this becomes 10 kilometer. So, break even amount comes in 10 kilometer. But if I want a break even point in value, that means in terms of the money, that how much I should get that from the customer, then you have another formula also, break even point in value, that is fixed cost divided by contribution per unit into selling price per unit. So, here that fixed cost is 100, contribution per unit is 10, and then selling price, that means you are charging from the customer 50, okay. So, you are charging 50, okay. So, therefore, it becomes basically 500. So, that means that day customer has to give 500 rupees total, that means value wise it is 500 rupees, that means you have to earn 500 rupees that day. So, this formula break even point in value is also there, and then fixed cost. So, this is fixed cost and selling price per unit divided by contribution per unit. This type of, this is given by PV ratio, okay. So, this is fixed cost divided by PV ratio, that can come like that. So, this is what that you have obtained, okay. So, this is PV ratio, okay, and then now we go to this one. So, contribution is equal to basically sales minus variable cost. If we talk about contribution, so contribution is very important. Contribution can be total contribution or it can be per unit wise also. So, if I want to know that what is the contribution of a day, I can find out sales in a day and variable cost incurred in a day. I can find out contribution in a month, then contribution in a month is sales in a month and variable cost incurred, this one, and it can be done per unit wise also. So, contribution is this one. Another formula is also there, contribution is equal to fixed cost plus profit, okay. So, contribution is towards fixed cost. So, we have, suppose you have recovered the fixed cost, naturally the excess contribution goes to profit. So, contribution is equal to fixed cost plus profit, okay. That day fixed cost was something and this is the thing. So, it is clear that why it is called contribution in finance area. Now, as long as the contribution is more than the fixed cost, there is a profit, no matter whatever is that thing. As long as contribution is more than the fixed cost, there is a profit. If you are having contribution which is less than the fixed cost, then naturally you are making loss, then you have to be careful, better not to do that business. And contribution is also defined as sales into PV ratio. So, PV ratio is basically, PV ratio is contribution divided by sales, contribution divided by sales. So, that will come out to be as a PV ratio. In the last slide, I showed you that selling price by contribution is 1 by PV ratio, that is why PV ratio has come here, but so PV ratio is equal to contribution by sales. So, sales minus variable cost, if we have sales minus variable cost is equal to what? Let us say sales minus variable cost is basically contribution, So, therefore, by that formula it is sales into PV ratio, class connection. So, sales into PV ratio. Okay. So, now you have got, so therefore, sales is equal to, you can find out variable cost divided by 1 minus PV ratio, because if you take this that side, so like that you can make manipulation, you should not get confused, and you can say that okay, if you take this portion this side, that means in this equation, if you take towards left hand side, so sales 1 minus PV ratio, PVR you can say, is equal to variable cost VC. So, therefore, sales becomes VC divided by 1 minus PVR. Here sales is in terms of the money earned. Now, about fixed cost will be contribution minus profit. See, because contribution is equal to fixed cost plus profit. So, therefore, we can say fixed cost is equal to contribution minus profit, and as we know that contribution can be written as sales into PV ratio. So, this is sales into PV ratio minus profit. If PV ratio is 1, suppose take the extreme cases, suppose your PV ratio is 1, then fixed cost will be sales minus profit, or profit will be sales minus fixed cost. Okay, so, profit will be sales minus fixed cost, and in that case what will be that? Suppose we have sales minus fixed cost becomes this one. So, sales minus fixed cost, PV ratio is 1. So, this becomes sales minus profit. Okay. All profit is equal to sales minus fixed cost. So, in this case, otherwise profit we had said that profit was equal to sales minus fixed cost minus variable cost. So, if you are seeing that if it is this one, so in this case the naturally the variable cost is 0. So, therefore, what happens that in this situation variable cost will be 0. So, when the PV ratio can be 1, because PV ratio, as I told in the previous slide, it is contribution by sales, and contribution is what? It is sales minus variable cost, So, if variable cost is 0, then PV ratio will be 1. So, that is what. And suppose PV ratio is 0, when? That means if PV ratio is 0, then by this formula fixed cost is equal to minus profit. That means fixed cost is equal to minus profit, and therefore, you are making loss. That means your contribution is 0. You are not getting any contribution. Naturally, in that case, your fixed cost will be causing you loss. Okay. So, you are not contributing to anything. So, that means this is equal to that. And profit, as far as profit is concerned, profit is equal to sales into PV minus fixed cost. By that formula we can get, by this formula sales minus. So, we can represent like this also, and sales in units will be fixed cost plus profit divided by contribution per unit. Okay. So, sales will be, because fixed cost plus, so sales in, so unit. So, we have said that this is a fixed cost, I need some fixed cost plus profit. So, this will be fixed cost plus profit, and sales, this will be PV. So, this is from that formula you can derive this also, that fixed cost plus profit, that much unit. That means I have to sell that much unit, that so that I can make profit. So, otherwise it will be fixed cost by contribution, that means there is no profit. That is why in the beginning this was told that break even point is fixed cost by contribution per unit, but here this one. But sales in value will be, you have to multiply it by sale price. So, therefore, it becomes fixed cost plus profit divided by PV ratio. So, sales in value will be this one. So, we can say this one. So, this is a general formula, and if I want to find out break even, that means make profit 0. Profit volume ratio, it is also called contribution to sales ratio. Profit volume ratio is equal to contribution divided by sales, and then percentage PV ratio. Usually most of the cases PV ratio is expressed in terms of the percentage, but when you use in the formula, then you have to be careful, you have to put in some fractional value, but most of the time you will see that they will always talk in terms of this one. So, that is why I have written PV ratio and also percentage PV ratio in terms of the percentage. So, this is change in profit, contribution by sales into 100, or we can also say it is change in profit divided by change in sales, because contribution will affect profit into 100. Now, it is also possible that PV ratio may differ from product to product. So, in an organization there may be 5 products and all of them may have different type of PV ratios. So, therefore, we have to use some method, otherwise you have to do analysis, otherwise you have to take average PV ratio, whatever is that thing. Now, this is about break even point up to this. Now, I am just mentioning you some related thing. Naturally, it is like this, that how to reduce the fixed cost, because you know it appears that fixed cost is a very important factor in getting the break even. Your break even quantity has to be high if the fixed cost is high. So, therefore, let us take an example of utilizing additive manufacturing, which is considered very expensive process, 3D printing, and let us consider a process of using selective laser sintering. Similarly, you can have selective laser melting also. In this selective laser sintering process, you have to do various processes. You will put various type of powders. It may be nylon powder, it may be a polymer powder, many type of things. Usually in selective laser melting we put metallic powder, here mostly the polymer type of this one. So, there will be you will make a product, but the product there will be powder. Powder comes from this cylinder, and with the help of roller it is deposited, it is compacted, and finally, so there is a powder delivery system, and then when you layer by layer you manufacture, so this piston will be coming down and you will be making that, you will be doing sintering. So, here we are giving some heat. That heat can be given by means of say something heater. Okay. So, initially you have to do preheating of powder also, that can be done by infrared, and then the heating can be done with the help of a laser also, laser beam. So, suppose laser source is there and this is the scanning mirror is there and it comes. So, there is some unsintered powder, that means sintered, that means that has not been, the particles have not diffused and they have not joined. So, we do a sintering process where it is not exactly melting, but you know that they will reach high temperature and maybe some cases there may be very localized melting and diffusion. So, they may get sintered, and then there is a movable powder bed build, that is called build platform, and here is a some type of resistive heater. So, now what happens that here in this case you are putting lot of powder, you have to make just one component, but for that purpose you have to do so many things. You have to put lot of powder, and lot of powder has to be preheated. Preheating itself may take about half an hour time or something, and then after that you start making that component. So naturally there is a fixed component involved. So now what I am telling, that suppose you want to utilize that this selective laser sintering machine properly, then more units we make in a day, we get more profit. So first of all, that you have to make more units in a day, hence the machine should be utilized properly. So we have to anyway pay for fixed cost, depreciation, maintenance, annual maintenance may be there, periodic maintenance that you have to do every 3 months, you do supervision, supervisor is required, that payment has to do. Hence better not to keep it underutilized. So in order to reduce the fixed cost, its utilization should be sufficient, so that your fixed cost gets distributed among various units. So for that purpose, that one paper one PhD student wrote, that is published in Journal of Institutions of Engineers India. It is not in the textbook material, but we are just giving that thing. So we are telling the utility assessment, evaluation of utilization factor. So I defined a utilization factor, that is time required for production and total available time. Suppose machine is in available time is too much, but time required for production is less, then utilization factor will be less. If UF is less than 1, then the machine is underutilized. So if you can, in your organization, if you can have this type of data, then you can alert your management that management should plan to get job orders from outside, because utilization is less than 1. If utilization factor is more than 1, the machine is overutilized, management may have to outsource the jobs or plan to procure additional machine. An organization may have a policy to run only one shift in a day and may have some holidays in a year. Suppose just one example, so suppose 6 hours per day is the production and there are 300 days in a year. So in that case, if UF is more than 1 but less than a threshold value, the products can be manufactured on the machine with provision for overtime. That means I am telling that as such, total time available is 365 into 24. That is another thing, that available time is 300 into 6, because only you work in a 300 days, but at most you can say. So therefore here utilization factor is coming 4.87. That means your utilization factor can be as high as 4.87. It cannot be more than that. Okay, that means if machine runs continuously, then you can say, okay, my utilization factor is more. So impact of utilization factor on cost. If utilization factor is 1, that is full utilization, then we make a formula and we say fundamental cost formula for 3D printing can be written as that C total is equal to C material into MR. So this is a mass of raw material needed for fabricating the part, and this is cost of that thing. C slicing into T design, that you designed and slice, but you have to divide this part by number of product, because this cost gets divided. And then C operator plus C overhead plus T build, that means time for manufacturing one, that means total time for manufacturing one item, and then plus C operator into TPP, that means for operators other post processing etc., whatever the operator does, for that also time is there. So you can find out the total cost of the product. Now utilization factor will affect the overhead cost in an inverse manner. Now this is assuming that machine is properly utilized, so you could give that overhead cost, but it lesser the UF, the more will be C total and vice versa. So therefore it has to be divided by overhead, because you have to recover overhead by less utilization only. So therefore you divide by UF and you put all that thing. I have just taken it out I divided it by UF here, but then took the common. So, this UF has been put on the top, and ratio all of actual cost to the cost with UF is equal to 1 is given by this. So, 1 is that you got C total with some UF, and suppose UF would have been 1, then this was like that. So, this ratio. So, this ratio tells many things. Suppose you can say that if your utilization is not proper, then your ratio will be very high. Okay. And we can when we start some purchase this one, so there are some uncertainties also. So, we can incorporate uncertainty in the analysis. One way is to do the uncertainties by means of the fuzzy set. And how effectively you can use a fuzzy arithmetic or fuzzy set also, it is also dependent on how you collect the data from expert, etc. Suppose we say total available time on a machine, I can represent as a triplet TAL, TAM, TAU. So, TAL means actual time lowest estimate, and TAM is most likely estimate, TAU is the upper estimate. Anybody can give that data, say something like you feel that it will run 4 hours, but at the worst case 2 hours, then 4 hours, and at most it will run 6 hours. So, give 2, 4, 6. Once you give this type of triplet, you can represent in terms of a triangular membership function like a fuzzy number. You can here plot TAL, TAM, TAU corresponding to TAM most likely estimate. You can assign the membership grade of 1, and corresponding to lower estimate it can be 0.5, corresponding to the upper estimate also 0.5, and then simple join it by triangle. So, triangular fuzzy number is little bit easier to operate, that is why we get. Now, utility factor can be computed as, suppose similarly the time required for production can be also represented as triplet. Then you have to find out utility factor, that means this ratio to this ratio, that can also become as a fuzzy number. So, it is basically we say it a fuzzy arithmetic operation of say division, you divide this time by this time, but it is basically interval. In interval arithmetic also we used to do that. In interval any number will be given as a interval, and we do that one. So, here what will be the operation, that here TPL, TPM, TPU, TPN. So, in the middle most likely by most likely. So, that will be intact, but TPL divided by TAU, that means low estimate of this divided by high estimate of this will give one extreme, and similarly TPU by TAL. So, this is what this one. So, this point has to be understood that we do like that. Suppose we have got two fuzzy numbers, one is AB, other is say interval number, other suppose CD. Then you have to understand that estimate can be AC and both are positive, let us say, and BD. So, it gives AC BD, that is fine. Low into low gives one low value, but the same thing if it is in division, then it will be inverse. Okay, CD. That means this is A by C, A by D rather, not C, and this is B by C. So, that is what we have done, and then we can plot. So, to assist the decision process about the utilization of 3D printing, we know utilization factor 1 is better. So, we represent the fuzzy number UF is subtracted by 1 and is denoted by index beta. So, beta is equal to UF minus 1. We can do like that, we can subtract, and decision strategy can be then given in terms of beta. If all the elements of triplet beta are negative, then the machine is underutilized, because UF is always less than 1. Every estimate is telling that. In that case, try to get job orders from outside. If all the elements of the triplet beta are positive, then the machine is overutilized. Then the possibility of overtime outsourcing and procuring another machine should be considered, because your machine is getting overutilized. Now, case of some elements of beta being positive and some negative needs careful consideration. So, this is due to uncertainty effect, you know, that one estimate may say that it is underutilized, other can say that it is overutilized. Here at some value of alpha cut means we just in a simple way we just take some member, membership grade, and that you have both the intervals, that is called alpha cut. So, that means at each membership grade level. So, okay, I am not giving you the very precise definition of alpha cut, but that means at different this one type of membership grade you do the, say for example, at alpha cut is equal to 2.5 we have the these values, at alpha cut is equal to 1 we have only one value here. So, case of some elements of beta being positive and some negative needs careful consideration. Here at some value of alpha cut the machine is underutilized and others it is overutilized. So, decision is dependent on how much risk management wants to take. In a simplistic way, the centroid of beta can be evaluated and machine is underutilized for negative values of centroid and vice versa. So, it is related to the risk thing, and we can compute the ratio R also, that cost considering the utilization factor divided by if utilization factor is 1. So, ratio R and cost can also be computed in the fuzzy form. However, care has to be taken when a particular variable occurs more than once in an expression. In that case, blind application of fuzzy arithmetic will provide wide range. So, something you have to do, that suppose other cost plus overhead cost by UF, I can say that like that, overhead cost plus UF is only this one and other cost plus overhead. So, this becomes 1 plus x by UF divided by 1 plus x. Now, if in fuzzy arithmetic, if something occurs 2 times, suppose we have got x plus say 1 by x. Now, you cannot, if you will do like this, that suppose for doing that, for some computation, suppose x is high. So, you say that upper limit of x, let us say you say that this is xu, and here you say I want to be very stringent and I take that lower limit of x. So, then this value will be unnecessarily very high, because in same expression you cannot say that estimate that one term is very high and other term is high. You can say high and low type thing. So, you have to do something like that. You can say that okay, this is upper and this is xu plus 1 by xu, or you can say it is lower xl plus 1 by xl, like that. So, in those type of situations, vertex method, that means you see the possible combination by which the values can change and you find out at all vertex and then take the value upper and lower limit, that will be better. Say for example, if you have 2 variable, so you have to say that I am going to take that say x and y. So, suppose you can say you can take one case x is low and another value is high, another is this is it is low, another is also low. So, low, 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 high, and this can be high, low and high, high, means 4 cases, and out of that you can decide that what will be the range. So, according to a vertex method, expression R has to be evaluated at 4 combinations of x and UF. For UF less than 1, the lower limit of R is obtained at lower limit of x along with upper limit of UF. For UF greater than 1, the lower limit of R is obtained at upper limit of x along with upper limit of UF. And similarly, for UF is smaller than 1, the upper limit of R is obtained at upper limit of x along with lower limit of UF. For UF greater than 1, the upper limit of R is obtained at lower limit of x along with lower limit of U. So, these are just some applications of the fuzzy set for some uncertainty, etc. And now, let us do some case study. Let us say I have made this milling cutter by 3D printing. So, the methodology developed in this work is illustrated by example. Detailed estimation of build time and cost is already discussed. Example of fabricating a polymer cutter in varying quantities is presented. Then an example is taken in which 3D printing machine is required to print 2 different products, part A and part B, in varying quantities. It is considered that an industry produces a polymer cutter on a SLS machine. Details of geometry of cutter, type of SLS machine, build time and cost are provided. it is assumed that machine operates for 6 hours daily, 300 days in a year. However, the lower estimate for machine operation is only 4 hours due to maintenance etc., and the upper estimation is 9 hours daily considering some overtime. So then you just make a table type of thing. Suppose annual production is 100, then production time estimates are given and utilization factor is given. Then you find out beta, then you find out unit cost for UF is equal to 1 and actual unit cost. So then you take annual production 300, then you make annual production 600. So you see that as you increase the number of units of production, then actual unit cost is decreasing. Actually, you are seeing that actual unit cost keeps reducing actually. So this is how that it is going on. So that is what that this one. So it can be represented by this one also, by graphically utilization factor for 1000 units it will be like this, and for 1500 units it will be even more, that means more utilization. And similarly variation of unit cost with UF is equal to 1. So actual unit cost is coming like this, and here that for 1000 units, and for 2000 unit if I make, then my actual unit cost will be lesser. So that is also depicted in a fuzzy way. So and if I produce two different products, so then part A and part B, then we have got production times, and then we have got this type of analysis we can do. So worth noting fact is that an increase in quantities of one part reduces the cost of both the parts. That is also seen because overall utilization is increased. It is seen that for full utilization of the machine, the cost is not dependent on the production volume, but it is dependent on the production volume if it affects utilization. Suppose you know that in the 3D printing, if it affects utilization, hence it is stressed that an organization should attempt to enhance the utilization of 3D printing machine. If it is properly utilized, then it is okay. The increase in the production volume of a part increases the utilization factor with a reduction in the unit cost. The uncertainty in the unit cost for high production volume reduces due to the low impact of overhead cost, and for the production of two different parts, the increase in the production of one quantity decreases the cost of both the parts. This is due to overall utilization of the machine. This is how that you can recover. So this is just one case study type of thing we have given. No need to get panic over these computations. These are just a lot of, we using Excel sheet etc. These things have been made. It is not just by hand calculation, and then we have drawn that, but essential concept you have to understand. Then finally, I want to tell one thing, that there are some non-quantifiable benefits. It's not that everything goes by number, just calculate break even and you decide that. You have to see company's mission also. Sometimes the company decides that considering the long term interest, even if you are getting loss, it will keep producing the items. Then what is the present focus of the company, if the company wants to get focused in that area. And then it is likelihood of success, like break even point is coming. Suppose it came 300 units, it's not that you will start producing 300 units, you will have to see the success etc. Then you have to see market conditions. Then you will see that what is the market conditions. Then you will see that customer goodwill, whether customer is actually having that what will be effect on the goodwill. Maybe one product may affect the sale of other effect. So all those aspects also we have to discuss. So this is how this thing. Finally, I want to tell you that in some books etc., people, I have not used much, but people show break-even analysis by graphical way also. So this is maybe we can say number of units, this type of diagrams they make. So let me also make that. So we say number of units we are making, and then they draw one line and they say this is fixed cost. Whatever is the cost, they take on this axis, and then they make this type of line, okay, straight line, because you see we are assuming that variable cost is, of course we have been assuming that cost per unit is constant, but sometimes the variable cost may be dependent on the number of unit. That means this line of variable cost is not a straight line, but you know that they are showing that this is variable cost, so this is fixed cost, this is variable cost, and then we can have that this is so total cost will be straight way from this, because in the 0 unit means total cost is fixed cost and more unit means total cost is this. So it is very simple, and then people can show the total sales per unit is known, so total sales, so suppose it is like this, so the sale price will be giving you something, so this is sales, total sales. So you see that here we are getting more unit we sell, more we get, again we are assuming that it is a linear behavior and we are getting that in a linear manner. So this is what that I am getting the sale, and this is cutting at this point. So where this point is cutting, that is the break even point. So this is BE, break even point is this, that means, and here till now there is a loss, and then here it is profit because you are making more than the break even point, say it is like that. So this type of thing also is done, and it is basically nothing but it is a very simple, you know, that mathematical type of equation, and it is based, can be done based on the class 10 knowledge also, but we have given, you know, formula, that contribution etc. But otherwise if you would not have known that, then also you can analyze by this type of method also, that how much is the sales and how much is the total cost, like that, with the help of these graphical things. And it also gives the clue that later on you can do some advanced analysis by taking the non-linear things also. Even fixed cost also may be dependent on unit, it up to some unit it is fixed, after that it may step up. Those type of things can also be there. So only today this much. Thank you very much for your kind attention, and we will conclude this. Okay, thank you.